Okay, now we're given a question 3, and the concentration C of t in milligrams per cubic centimeter of a particular drug in a patient's bloodstream is given by this equation. C of t equals, maybe I better write that out so you can see it. C of t equals 0.3 t over t squared plus 6t plus 9. And that's on the interval 0 is less than t, which is less than 12. There's something else to keep in mind, and that's this. T squared plus 6t plus 9 equals t plus 3 squared. So now, let's take the derivative of that. Oh yes, where t is the number of hours after the drug is taken orally. Find the critical values of C of t and the intervals on which the drug concentration is increasing and the intervals on which the drug concentration is decreasing, and the local extrema. Well, the first thing we'll do is find C prime of t. And we're going to use a quotient rule. And so we're going to hold this constant, but I'll square it. So t plus 3, it's more convenient to write it this way. And if we square this quantity squared, we get it to the 4th power. Now, we'll take the derivative of the numerator, and that's going to give us 0.3 times our denominator, which is t squared plus 6t plus 9, and then minus, and we'll multiply by the numerator, 0.3t, times then the derivative of this denominator, which will be 2t plus 6. Now notice, this denominator will never be negative. Never. It will always be positive, because it's raised to the 4th power, and this expression can never go to 0 on the interval 0 to 12. So we no longer have to worry about that. Anyhow, let's multiply this thing out, and put our denominator down here. T plus 3 raised to the 4th power, and that's going to be 0.3 t squared plus, and 0.3 times 6 is 1.8, and we have a t there, and 0.3 times 9 is 2.7. Multiplying through by negative 0.32, we get negative, and that's going to be negative 3 times 2 is negative 0.6 t squared, and 0.3 t times 6 is, and that's a negative 1.8 t. Now notice the 1.8 t's divide or add out, and the difference between 0.3 t squared and negative 0.6 t squared is going to be, and we have a positive 2.7 there, it's 3 to the 4th. That difference is going to be negative 0.3 t squared. Okay, so now we have to find the critical values. So we're going to set C prime of t equal to 0. So C prime of t, and let me rewrite that one more time, is 2.7 minus 0.3 t squared, and that's over t plus 3 to the 4th power. And we're on the interval 0 is less than t, which is less than 12. So now let's set C prime of t to find the critical values equal to 0. That means that this numerator, we just have to set the numerator equal to 0 because the denominator is never going to take this thing to 0. And so we're going to set 2.7 minus 0.3 t squared equals 0. In other words, you're going to have 0.3 t squared equals 2.7. If we add this quantity to both sides and then switch sides, here we go. So now t squared dividing through by 0.3 equals 9. 0.3 into 2.7 is 9. So t equals plus or minus 3. But we're going to throw out the negative because negative 3 is not on this interval. So t equals 3. Now let's draw a number line from 0 to 12. And we'll put 3 in here. And let's see what the slope is, c prime of some value in this interval, c prime of 1. And when I replace t with 1, I get that c prime of 1 is greater than 0. Now I'm going to do the same thing. You might want to check me on your calculator or whatnot. And I'll pick a point in this interval like 10. And c prime of 10, replacing t with 10 and squaring that, we get 100. And so this side will dominate, the negative will dominate, and will be less than 0. So this tells us that this thing is increasing. By the way, the critical value is at t equals 3. So our critical value is t equals 3. And it's increasing on the interval 0 to 3. And I'll put signs here to indicate that because it's greater, c prime is greater than 0 in that interval. And it's decreasing on the interval 3 to 12 because the derivative is less than 0 on that interval. Oh yes, we have to find the max, the local extrema, which is a max. And so we'll look at c of 3. We know that 3 is the horizontal coordinate. Let's see what c of 3 is, and when I evaluate that, I get 0.025. So now we know our max is at x equals 3, and the max is 0.025. And if we were to graph that, if this is like 0, oh, excuse me, I'm not going to graph that. I've graphed the behavior. We don't have to graph it, yeah. And so we're done. We've done what they asked us to do, yeah.